Scott Cunningham, ArcLight Dynamics. This video we're going to be discussing manual data input and position recovery. So I got my machine powered up. I have set my machine 0. Okay. And what I want to talk about is typing in G-code manually to make the machine move to different positions. Okay. So to do that, you're going to click on the manual data input. Okay. So there's a lot of resources out there on how to write G-code and reading G-code and whatnot. G-code's not rocket science. It's pretty straightforward. So I'm going to just show you a few brief ways to make the machine move around so that you can precisely position the machine where you need it to be. So let's say, for instance, bring the torch down. We're going to 0 my X, Y, and Z here. So let's say that's my job 0. Okay. Well, let's say, for instance, you wanted to move the table 1 inch over to the right. Okay. Well, you could attempt to jog it and then, carefully change your jog type to carefully position it, back and get, I can keep going and pretty much almost get there. But there's an easier way to do it. Okay. So that's what we're going to talk about today. I'm going to go back to continuous. And so say I want to move it over so it gets to the 1 inch position. What I'm going to do is type in some G-code here. Now the first type of G-code I'm going to talk about is called a G0 move. Okay, a G0 move is a rapid move. So if I type in G0, now make sure you use the 0, not the O, and then I say X1, okay, I want to move the X axis to the 1 inch position, keeping in mind that these moves are all relative to where I zeroed out. So if I tell it to move over 1 inch, it will move over 1 inch. If I tell it to move to -1, it will move back this way. Okay. So once you have that line typed in there, G0, X1, you can hit enter. And the machine rapid it over 1 inch. Okay. So now, let's say I want to do, and now, so that's a G0 move. It is a rapid. It will move as fast as possible. So, for example, which is 600 inches a minute. Didn't pick up that much speed because it was only a short run that time. But let's say I go G0, Y10, and then hit enter. It picks up, moves pretty quickly. Okay. Now, also, I could do multiple moves at the same time. Say I do G0, we'll do X5, and then Y5. Okay. Hit enter. And now the machine moves in a diagonal to get to that position. I can also move back to the 0 position by simply going G0, X0, Y0, hitting enter. Now we're right back to where our part 0 was. Okay. So now let's talk about the G1 move. Okay. G1 move is it's a move with a feed rate. Okay. So it's a move at a prescribed feed rate. So if I go G1 and then Y10 and hit enter, now nothing happened because this is the first time I've done a G1 move since I powered the machine up. I get this message in here, it says can't do a G1 move with a 0 feed rate. Currently the machine has my feed rate at 0 because I haven't told it what the feed rate should be. So I have to communicate that. So I go G1, Y10, F, and I type in my feed rate. And this is going to be in inches per minute. So a lot of times I'll do 50 inches per minute. So G1, Y10, F50. Now I hit enter. And now the machine will move at my slower prescribed rate of 50 inches a minute. Okay. So now that I have done that, the next time I want to do a G1 move, say I want to go G1, Y 6.7, and then X 8.9. Now I'm going to move a diagonal move to that position at my prescribed feed rate, because as you notice, I didn't put in a feed rate. Well, if you don't put a feed rate, it will use the last feed rate it was given. Okay. So if I wanted to change that, I would put in, say, G1, Y 0, X 0, F 250. Now moving at 250 inches a minute back to the 0 position. Okay. So that is how you can use the manual data input. This is very useful when you want to set up jigs and do different things like that. Say you have a jig that is, you can build jigs that conveniently mount to the edge of the table, that mount to the edge of the extrusion, and you can pull them on and off. And basically what you do is you set it up, your jig's in the set position, it's a set position off the 0, the machine 0, and so that you can know exactly where your part is. And a lot of people do this when they want to cut tubing. They'll set up a jig so they can lay their tubing down and then have multiple tubes laid out, and so that the tubes are a known distance apart from each other. Okay, so this is one way. Say you ran an operation on, one part, you could then do a, move the machine over a prescribed distance to the next tube, and essentially zero it out, create a new job 0, and run the part on that new tube. So it's a very handy way to move the table in a prescribed motion. So now I want to talk about doing a essentially position recovery, okay, on your table. And this all relates to having a machine 0, okay? So first off, a couple things I want to mention. I'm going to get out of the manual data input back into auto. Now once you're in the auto, you can jog manually, okay? So I want to talk about position and ways that you can lose your position. One way that's obvious that you're kind of out of luck is while you're cutting, your plate moves, okay? If your plate moves and you really don't have any set position where it was before, you just have it sitting on the table, and your plate is moved, you're kind of out of luck. You really there's no way to get it back in the right position. And that's why we have these material stops here. So, when you get your table, your material stops will be kind of positioned on one end for shipping. You can spread these out, loosen these up, slide these down, and then position them down along the table so that, basically you can spread out and line a piece of material up against it. And the beauty of this is it allows the machine you to position your material in the same spot each time. Okay. So a couple things about these stops. They're fully adjustable, and you will want to fine-tune these to the actual motion of the torch. What I recommend is get a known straight edge, set it up against these material stops, and then run the torch down the edge of that straight edge and determine, are these stops relative to the motion of the torch in the right spot. If they're not, adjust them in or out. Okay. You can also adjust the angle of these stops so that they can they'll catch more of the plate, or you can rotate them lower. One of the biggest things you want to watch out for with these stops is if you cut really close to the edge, you can come along and hit the edge with the torch, and that can mess up your part. So you can rotate them downwards so that they don't stick up above the edge of the plate. Okay. So if your plate moves and you don't have it against some physical stops, you're kind of out of luck. But let's talk about some other ways you can lose position. The most common is your gantry itself physically runs into something, and that is usually going to be something on the rails, as far as a welding BB or some debris from grinding, especially if you grind next to the machine. You have to be aware of, you want to wipe your rails down when you're done with them. Before you fire the machine up, I recommend taking a brush and just brushing off the rails. And then you know that there's nothing on there that's going to cause a problem. You leave something on the rails, a wrench or something like that, that gets in the way of the gantry. What it's going to do is stall the motors, and it's going to stop the gantry from moving. And what happens is the machine will think the motors have moved, whereas the motors haven't. And so the machine thinks it's in a different position than it actually is. And so I want to talk about how do you recover your position if that happens. Okay. So first off, you have to, as always, have your machine zero properly set. Okay. So let's just come back down here. What I'm going to do is just redo my machine zero. And as I said before, setting a machine zero is done by using the home buttons, not by using the zero buttons. So if I go home X and then home Y, so the machine homed itself and created a new home position. It's the exact same spot as it was, but so now let me click this button here to clear this tool path, get rid of all those lines. Now you're gonna go to your machine zero or your job zero. So let's say I was gonna cut my part out right here. Okay. So the biggest thing, and I won't always do this on when I'm cutting out individual parts on, say, scrap like this, but if I'm doing a big nest, doing this next step is very important. So let's say I want to set this as my job zero right here. Okay. What you want to get in the habit of doing is writing down your X and Y coordinates, because those are very important. If I write down this X and this Y coordinate, those positions written down, I can always recover my position, even if I stall the motors out or the computer completely shuts down. So what I recommend is have yourself a piece of line paper or a graph paper, something where you can just, each time you do a nest or you're doing a big cut, take a moment, write down these coordinates before you zero out for your job position, and then have them set aside so that if there is a problem, you can always get back on track. Because often you can get close, but if you want to just get close by hand, but often it can be difficult to get right back to where your job position was, and so on a tight nest that can cause problems. Okay, so with these position, my X and Y position written down, I'll zero out my X, my Y, my Z, and that produces my job zero. Okay. Let's talk a little bit about how do you. We've discussed different ways that you can lose position. So now I'm going to cause the machine to actually lose position. So I've actually put in a little, purposely set a wrench on my rails in such a way that it will jam up the machine in its motion. And so you might be able to hear that. You can say, oh, my machine, it just jammed up, and so the gantry is completely out of square. So my machine thinks it's in a completely different location than it is right now, because the motor's stalled, and so everything's completely out of whack. And so how is it that I can get back on track? Well, as long as I've written down those original coordinates, my first step is to simply home my Y and home my X. So first we're going to home the gantry, and the gantry is going to straighten itself out, because right now it's completely wrecked. It was about an inch out of square there. And so now we're going to home the X. So now we're back in our original machine 0 point. And if I go 0, 0, okay, now what I can do is I want to get back to my machine 0 or my job 0 and finish my cut. Well, I'm going to go into manual data input, and then I'm going to type in, as we did before, we're going to go G1, and we're going to go X, and pipe in my numbers, which were 9.452, and then Y 2.452. Okay, I'm going to hit, I don't have to put in the feed rate because I still have the last set of feed rate of 250. If I wanted to change that, I could, but 250 is fine. I'm going to hit enter. Machine moves at 250 inches a minute, right back to where my machine 0 was. And so now we're right back at the job 0. I can zero back out, go back through my code, figure out where I left off, and rerun the part. So I've completely recovered my position. Okay? So that's key. As long as you write down those coordinates so that you know the coordinates between your machine 0 and your job 0, you know you can always recover your position. Okay? Now, one good thing about this system is a lot of times if we shut down the computer, or say you have a power failure, Command CNC will do a very good job of remembering this position. Okay, so when you power it back up, it will be back here 99% of the time. And if it is not, or if there is a problem with the software, then again, having your coordinates written down will allow you to recover it.